Welcome back to the second part of Lesson 7.3, Understand Experimental Probability. Today we will solve some practices and problem solving in your textbook pages 370 to 372. Let's start with page 370. Do you know how? In items 4 to 6, you're going to complete each statement. Kelly flips a coin 20 times. The results are shown in the table, where H represents the coin landing heads up and T represents the coin landing tails up. So what is theoretical probability that the coin will land heads up? This is 50%. Number 5. Based on the data, the experimental probability that the coin will land heads up is 55%. Number 6. The experimental probability is greater than the theoretical probability. Now let's do practice and problem solving in your textbook page 371. Number 7. The table shows the result of spinning a wheel 80 times. What is the relative frequency of the event spin A3? Take note that the outcomes are 1, 2, 3, and 4, and the frequency 8, 22, 18, and 32. So the relative frequency of the wheel landing on 3 is the number of times an event occurs divided by the total number of trials. The number of times an event occurs is 18. And the total number of trials is 80, and this is equal to 25.5%. Now let's do number 9. Jess spins a pointer 25 times and finds an experimental probability landing on 3 to be 4/25, or 16%. The theoretical probability of the spinner landing on 3 is 1/4, or 25%. Why might there be a significant difference between a theoretical and experimental probabilities? More trials are needed. After she conducts more trials, the experimental probability should approach the theoretical probability of just event. Number 11. The theoretical probability of selecting a consonant at a random from a list of letters in the alphabet is 21/26. Wayne opens a book, randomly selects a letter on the page, and records the letter. He repeats the experiment 200 times. He finds the probability of selecting a consonant at random, which is equal to 60%. How does the theoretical probability differ from the experimental probability? What are some possible sources for this discrepancy? The theoretical probability is much greater at about 81%, while the experimental probability is 60%. The experimental probability may be less because the distribution of letters in words is not random. There are more vowels than consonants on a page. Let's do number 12. Higher order thinking. 7 different names are written on 2 sticks and placed into a cup. A stick is chosen 100 times, out of which the name Grace is chosen 23 times. How do the theoretical probability and experimental probability compare? Explain why there is a discrepancy between them, if there is any. The theoretical probability for choosing Grace's stick is 1 out of 7, which is about 14%, while the experimental probability is 23 out of 100, or 23%. The person choosing sticks may not be mixing sticks before drawing from the cup. The selection may not be random if the person can see the names written on each stick. Number 13. Each of 3 friends flips a coin 36 times. Angel records tails 20 times. Michael records tails 17 times. Fernanda records tails 23 times. Find the relative frequency with which each friend records tails. For Angel, it's 20 over 36, or this is about 56%. For Michael, it's 17 out of 36, or this is about 47%. For Fernanda, she records tails 23 times out of 36 times. This is about 64%. Letter B. Which friend has relative frequency that is closest to the theoretical probability of flipping tails 36 times? Explain. It's Michael. The relative frequency for Michael is 47%, which is closer to the theoretical probability of 50% than anyone else's relative frequency. Let's do number 15. The best player in a basketball team makes 75% of all free throws. The second best player makes 70% of all free throws. And the third best player makes 65% of all free throws. Based on their experimental probabilities, estimate the number of free throws each player will make in his or her next 40 attempts. Explain. For the best player, using proportional reasoning, he makes 75% of all free throws out of 100. And this is equal to x over 40, where x represents the experimental probabilities. Out of 40 attempts. So x equals 30, so it's about 30. For second best player, it's 70 out of 100 equals y over 40. So multiplying each side by 40, y is equal to 28. So about 28. Now for the third best player, it's 65 out of 100 equals z equals 40. Multiplying each side by 40, z is equal to 26. So this is about 26. And we are done! Don't forget to answer items 8, 10, and 14 in your textbook pages 371 and 372. Also, please check your Pearson account and do your assigned test. That's all for today. See you in the next lesson.